Hello everyone, this is MH Mubashir, your instructor for BTC 509. This is tutorial number 4, and in this tutorial I'll be talking about how you can search for a template to model a specific protein. If you want to model a specific protein which structure is not available, you can model that protein by identifying the templates for it. So to search for a template, first you have to go to the server NCBI. So I'm typing NCBI here. So let's go to that server. And as we are working with the protein XA21, so let's go search for the protein XA21. So I'm searching for the templates, and also I'm searching for the structures for XA21. Either any structure of this XA21 is available or not. So you see that it is showing that we can have 3 structures for XA21, but this might not be the true, because whenever you are clicking here and open it, you can see that all these 3 structures are not the structure for XA21. You see, this is the structure of OSERC2, which is the associated protein of XA21 but not XA21. This is also the structure of OSERC2. This is crystal structure of some other proteins, but certainly not XA21. As we don't have any structure for XA21, we can model this protein. We can predict the 3D structure for this XA21. And to do so, first we need to search for the template. And if you want to search for the template, you need the FASTA sequence for this protein. And we already know that to get the FASTA sequence of this protein, you have to click protein here. And then the first result we have got here, the first one, it is of 1025 amino acid. And I have said to you several times that this is the right sequence for this XA21. So I am clicking on FASTA to get the FASTA sequence of this protein. So after clicking the FASTA, you will get the amino acid sequence for this protein. So what you will do, you will run a blast for this protein. So I'm clicking here, run blast. Whenever I'm running the blast for this protein, it will automatically add the accession number. You can even paste your FASTA sequence here. You can just delete it and paste the FASTA sequence here. If you want to model 100 to 400 amino acid, then you can type 100 here and 400 here. And then the database. So for the databases, we'll be using PDB. Why? Because we want to model our XA21 protein. To model this protein, you need a template, and that template must have a structure, 3D structure. Either it can be crystallographic structure or NMR or cryo-electron microscopy. So for our case, we are clicking protein data bank here. So after clicking protein data bank, we can run blast. Remember, you might get errors sometimes, so you have to try again. Okay, you see we're having error, so I'll be doing this blast again. It is doing blast. You see the status is searching, so it will generate some result for us. So let's wait for a minute to get the results. Well, you see, we have these templates, and this is sorted according to the e-value, and I advise you to always sort the templates based on the e-value. Okay, let's see it here. So the first one is we have crystal structure of free FLS2 ectodomain. That means this is a crystallographic structure, and the structure of this FLS2 will be quite similar to the XA21. Why? Because the amino acid sequence of XA21 is quite similar with this protein FLS2, and we'll be seeing those shortly. So this can be our template. So if we take one single template, so this should be our template. So I'm unmarking this one. So this can be the first template for XA21. Say for an example, I want to take 5 templates for XA21. So the second one shouldn't be this one, because this one says that this is the crystal structure of FLG22 in complex with the FLS2 and BAC1. That means FLS2 is there. Also with this FLS2, we have BAC1 and FLG22 proteins. And we already extracted the information for FLS2. That's why we don't need this one, because the structure of FLS2 here and here is the same. And as we already have the structure of FLS2 or amino acid sequence of FLS2 from this first one, we are not considering the second one. Now we can consider the third one, because this is a different receptor kinase protein. So I'm selecting this one. For this one, this is RGFR1. This is also not similar with first 3, so I'm selecting this one as well. And then the crystal structure of PEPR1 8PEP1. This is also a different protein, so I'm selecting this one as well. So for this one, this is TDIF TDR complex, so I'm selecting this one as well. So if we want to take 5 templates for our XA21 protein, these 5 templates will work. So if you want to see the faster sequence of these proteins, or if you want to see the 3D structures for these proteins, you just open it in a new tab. So I'm opening all these sequences in new tabs. So just click faster for all the cases, so you will have the sequence for all these proteins. For this tutorial, I'm taking this up to now, so we know that how can we search for a template, and then we also know that how can we select the templates and how we can see the faster sequences of these templates. In next tutorial, I'll be showing you a very important thing, which is multiple sequence alignment.